Hey boys and girls, welcome to Math with Dr. J. I found an amazing method that will make our life so easier with LCM, GCF, working with distributive property, and also, guess what? Simplifying fractions. So, you probably heard this before. You may have seen people talk about it before. You may have heard news about it. Have you anyone ever heard about the birthday cake? Sounds familiar? Let's be more specific. We're going to talk about the upside down birthday cake. In some cases, you may hear others talk about it as the ladder method. So let's get ready for that. The L method, ladder method, whichever way you want to call it, is still going to be an amazing method that we'll be using today to make sure that everyone leaves this lesson knowing how to get the GCF, LCM, how to use distributive property, and also how to simplify fractions. So first things first, let's get two numbers. So these two numbers are going to represent a few things. We're going to have the first GCF of 24 and 36. We're going to also incorporate and show how effective this is to show the sum of 24 plus 36 as a sum of two whole numbers, and then we're going to also show we can use that to simplify this fraction of 24 over 36, right? So the order that they come in does matter when it comes on to the fraction part of it. So, but let's get to the amazing piece of it that I want to share. So first things first, you turn your cake upside down, right? Once you turn the cake upside down, you shift the bottom of the cake right here. So what's in the bottom is going to actually be the two large numbers. So these numbers that we're trying to find everything up is going to be right here in the bottom of the cake, alright? So now, normally you can go with the biggest number, different numbers, but for the sake that everyone can see, we're going to start off with a prime number. More than likely, the lowest prime number that goes in the both. So let's get started with, let's say 2. 2 is the lowest prime number, so let's get started. So whenever we do that part of it, we're going to actually add another layer to the cake, which is going to be another piece of the cake right here. So 2 into 24, work with me, that's going to be 12, right? Now 2 into 36, that goes 18. But look again, these numbers end with 1 and not end with. They end with 2 and 8. To the end with 2 and 8, that means we can still get more factors of 2 out of them. So let's go again, one more layer of the cake. Notice that our cake is structuring upside down cake. Alright, so we have 2 into 12, that goes 6 times. Awesome. 2 into 18, that goes 9 times. Oops, no more 2. 2 is not common in both. However, they are both multiples of 3. Therefore, 3 is a factor of both of these numbers. So let's go. 3 into 6, that's going to actually go, come on, 3 into 6, 2 times. 3 into 9, 3 times. So we've actually reached our goal with the birthday cake method. Pretty much what this means is that when we're doing the upside down birthday cake method or ladder method or L method, whichever way you want to call it, actually, where our goal is to actually get either one prime number or both numbers in the bottom as prime. Once we get that, we're going to use it to find all different amazing things. Now, this is the part that I want us to understand first. So if you have any question about that part of it, just feel free to let me know in a comment and I'll clarify it for you. But this is the part that we want to understand first. Once we get this over here, we have nothing to worry about, because look how easy it is now to find the GCF. Let's color code everything. The GCF will be green, right? The GCF itself is just gonna simply equal to, you're gonna see how amazing this is. And no factor tree is helpful and everything, but look how wonderful this is. The GCF is just the product of your factors that are common. All is now working with them. They're the GCFs we're getting. So let's go. 2 times 2 times 3. So here we go. Now the product of these factors will give us our GCF. So that's 2 times 2 is 12, 2 times 2 is 4, and 3 times 4 is 12. So therefore the GCF is equal to 12. Now we're not done yet. Remember, I promised you that we're going to also use this to find LCM. I know you must be like, I don't know how it's going to happen, but we're going to make it happen. So let's see, LCM. Now the LCM, as we all know, is the least common multiple. Awesome, you guys got it. So the LCM is just finding, let's see, look at this here. All we're doing is that we're writing a big L, and this is one reason why it gets called the L method as well, because the L method comes from the LCM finding part of it. So a lot of people call ladder method because if you look, you're stepping in a ladder going up. Our people may call it upside down stairs looking at this case, but we know what we're gonna call it. I love that name, upside down birthday cake. So let's go. Well, all we're doing right now is finding the product of all the factors in the L. So therefore, see, I put the multiplication sign to make it easier for you. So let's put them out right here. 2 times 2 times, come on, 3 times 2 times 3. So therefore, 2 twos, 4, 4 threes, 12, 2 twelves, 24, 3 24, 72. So amazing. We just found the LCM without having to do extra work. See, this method is awesome. I'm so excited. I know you may be wondering why am I so excited, but let's take a quick look into the distributive property to see how that works along with this. Look how amazing this is. We know that the distributive property simplified out to this right here, which is equal to A times C plus, no, A times B first. I'm not going to shift the orders up. A times B plus A times C by simply distributing the A into the parentheses. Now the goal right here when we're going to write two numbers here as a sum using the GCF, we're working on this portion right here, right? So now one thing we need to know, how amazing this is that because the GCF itself, remember, GCF itself is the highest common factor, therefore it goes into both number without leaving a remainder. So we have the GCF as our A, we plug it outside here, and then the great thing about this is that all the steps that you will take using the GCF and finding dividing by each number, you already have everything here that you need. The two last numbers here will be your B and C. So I know you're saying this is too good to be true. If you don't believe me, go ahead and try it out. Look at this. Amazing. Right? That's the distributive property written there as a sum of two numbers with the GCF. So isn't that amazing? We're not done yet. We have one more thing I need to show you. The fraction piece of it. If we need to simplify this fraction, typically what we do is that we have 24 over 36 and then we want to divide by the GCF to make sure that we get it simplified, right? So that's going to be divided by 12, divided by 12, come on, divided by 12, and that's going to be equal to 12. 24 divided by 12 is going to equal to 2, and then 12 to 36 divided by 12 is equal to 3. Now how amazing this is that we're really going to get our numerator here. You must be like, he's crazy, but look at this, denominators in this column here. So therefore in the end we can get our numerator, and then we're going to get our denominator. So we found some amazing things here today. Actually, we just found the GCF using one method. In one method we found the GCF. We also find the LCM. We also express a sum of property, and we also simplify both numbers again as a fraction. So this method is truly amazing. So for anyone out there something or having trouble with GCF, LCM, or even using distributive property or even simplifying the fractions, this is a great way to go. It takes a little bit longer, but that's a great way for you to get the idea that you can do all of this right there all at once if you're doing a question that involves all of these steps. So this method has been extended to match and give you four answers any different way you want to go about it. So once again, if you have any comments or any concern, please free let me know so I can actually address those and we can take care of it from there. Alright, well, once again, thank you all for watching, and I'll see you guys next time.